Okay, Miss Davis said that someone wanted me to go over part 3 of the lab. So this is Snell's lab. I'm assuming that's what the lab is that we're discussing. So part 3 of Snell's lab. So in parts 1 and 2, you knew what your light wave was going into. Water, glass, air, water. So you knew the materials. But for part 3, we're doing mystery materials. Now, for the mystery materials, number 11 and 12, you're going to do mystery A and mystery B. I've already set this up, so I have mystery A, and I also have air, because it asked me to go from air to mystery A. And my laser is on, okay? This says you get to choose your incident ray, so it really does not matter what your incident ray is. I haven't moved this at all. And I'm just going to pull out my protractor and measure what angle is it coming in at. So here's my protractor. I'm going to line it up with everything. So the 0 is lined up with this dashed line, which remember is our normal. And then even my 90 is measuring right here on the flat surface. And it looks like my light ray is coming in somewhere between, what is this, 40 and 50. So this is probably 45 degrees. So I will come over here and I'm going to type in 45 degrees, okay? That's my angle of incidence. My refracted ray is something I have to measure. Okay, so if my angle of incidence right here is 45 degrees to the normal, I have to come down here and measure my refracted ray from the normal. This angle is going to be starting at 0, and we're going to go 5, 10, 15. That looks like 17 to me, so I'm going to type in 17 degrees. So my refracted ray is 17, and now I have to calculate the index of refraction for mystery A. I'm looking for n. That is my unknown. So let's go over here and let's actually use Snell's law, okay? So Snell's law, remember, is n1 sine of theta 1 equals n2 sine of theta 2. Well, if I were to make a given and find list from the information I have from my lab, I actually know that N1 for air is 1. And it has no unit. It's just a coefficient, okay? Theta 1 was what I measured, and I said that was 45 degrees. I just left it alone. I let it be 45 degrees because that's what the computer put it at. You can change the angle if you want. That's perfectly fine. You're still going to get the same number as me in the end, okay? And then my refracted ray, theta 2, I measured that to be 17 degrees. Now, if you change your theta 1, if you do it at a different angle, you're going to get a different theta 2, but we're both going to get the same answer for n sub 2. That's what we're looking for, the index of refraction of mystery A. So let's plug in everything we know over here. So for n sub 1, I'm going to plug in 1. Sine stays there. That's a function. But theta 1 is 45. 45 degrees. Make sure you're in degrees and not radians. N2 is actually the variable I'm looking for. So I'm going to leave it there. And sine of theta 2, so sine is the function. Theta 2 was what I measured, 17 degrees. And these two numbers, n sub 2, the index of refraction, and sine of 17, they are multiplying. These two numbers are multiplying, and these two numbers are multiplying. Don't worry about this, the fact that this is a function. It's still multiplying. So we're not actually going to do the inverse sign this time because we're not looking for theta. We're looking for n sub 2, which just multiplies on the front. So if I'm multiplying, I'm going to divide by sine of 17 to get it to move to the other side. I'm going to take the entire function and I'm going to divide it. Sine of 17. Now, when I divide both sides of the equation by sine of 17, I'm going to get n sub 2 all by itself. But here's the deal. 1 times the sine of 45 is still just the sine of 45. So when I go to plug this into my calculator, I'm not even going to include the 1. I'm just going to say sine of 45. Oops, I'm sorry. I thought there was a parenthesis there. That's okay. Delete. There we go. Sine of 45 divided by sine of 17. equals sine of 45 divided by sine of 17 is 2.41 and so I'm going to actually do 2.42. That's the number I'm looking for. I can go back over here. I can do 2.42, and then speed of light in the material. Now this comes from our packet as well. We talked about this. It's the second to last equation. If now I know the index of refraction of my unknown material, now I know N. I also know what C is, and what I'm trying to find is V. I'm trying to find what the speed of light is in this material. Now, here's a cheat for you. The material for Mystery A is actually a diamond, and you can actually compare it to the list of indices of refraction down here. 2.42 is the most, that didn't sound right. It's the slowest, it's the most dense. That's what I was trying to say. It's the most dense of materials, so it slows down the light waves the most. So 2.42, which is the index of refraction we just calculated for Mystery A, we want to know how fast light travels in that mystery material, which is actually a diamond. So here we go. We're going to put this equation down here now. V equals C over N. Well, I know V is what I'm looking for. C is 3 times 10 to the 8th meters per second, so I'm going to plug that in. N is 2.42. I just solved that. And there's no variable. There's no unit. I'm sorry, I keep saying the wrong words. There's no unit behind that one, okay? So we're going to take this big number divided by this smaller number, and that's going to tell us the speed of the light ray in that material. Oh, yeah, perfect. So I'm going to do 3 shift log 8, 3 times 10 to the 8th, divided by 2.42. That's how fast the speed of light, that's how fast the light is going in that material. This is its speed. So it's got no times 10. Okay, there's no times 10 here. So it's 123, comma, 966, comma, 942. Now, if I want to write this in scientific notation, I will, but let me go ahead and write it exactly how I see it on my calculator. 123, comma, 966, comma, 942. Yes, it's 942.1, but with such a big number, that 0.1 means nothing, okay? This is meters per second because it's a velocity, but if I wanted to write this in scientific notation, because usually I do, I would put the decimal in between the first two numbers, 1.23. Oh, I would probably round the 3 to a 4, actually, because of that 9 right there. And then I would count 1, 2, 3, 4, 5, 6, 7, 8 times 10 to the 8th meters per second. Now that's really close to the speed of light in a vacuum, which is 3 times 10 to the 8th, but it's about half, okay? It's about half the speed. It really slows that light down when it enters into a new medium that's as dense as a diamond. So we go back here to our part 3, 1.24 times 10 to the 8th power meters per second. Okay, and we type that in for our calculated speed of light in that material. Number 12 is the exact same, but now you're doing Mystery B. So you'll come over here, drop down, go to Mystery B. Personally, the darker this is, I can tell, the less dense this material is. So personally, I know Mystery A is not going to be as dense as Mystery B, and I did not remove anything yet. You can already see that the angle is a little bit bigger than Mystery A was. Mystery A was a tighter angle than Mystery B. So you're going to do the exact same thing. You're going to calculate those things after measuring your angles. You get to choose the incident ray. So you choose where you want it to start. Hopefully that helps.